Now we're going to take a look at simplifying complex fractions. This really isn't any different than what we just saw, except for we've got one extra step where in that denominator in this case, and I'm talking about this being our denominator, this whole expression is our denominator, needs to be added before we can divide. Order of operations. Fraction bars act like a grouping symbol. So this fraction bar tells us we have to simplify the numerator and the denominator before we divide. Our numerator is simplified. It doesn't look real simplified, but it is. It's a single expression. Our denominator, however, has addition, so we've got to add those together first. Now, before we add fractions, we have to have a common denominator. The factor that's missing from our first one is x plus 1. Remember, you have to multiply by a fancy form of 1 so that you're not changing the value of the expression. And our second term is missing that x minus 4. So, multiplying here by 1, we get x plus 1 over, and we'll leave this in factored form because we want it factored before we cancel. And then we've got 3x minus 12 over x plus 1, x minus 4. Now all of this in red is just the denominator of the original expression. I haven't written that numerator down again. We'll get back to that. So combining our like terms in the numerators, we've got 3x plus x is 4x. 1 plus negative 12 is negative 11. All over x plus 1, x minus 4. Okay, so now we've got our denominator simplified, so I'm going to rewrite this expression with my simplified denominator. So my numerator is 3 over x minus 4, all over 4x minus 11, over the quantity x plus 1, x minus 4. Now, we are dividing two fractions. Right here, this bar tells us to divide. The way that we divide fractions is we multiply by the reciprocal. Some of you may know copy.flip or keep change flip, I think is one that I hear quite a bit. So I'm keeping the numerator, changing from division to multiplication, and flipping my denominator. And then we're going to take a look. Our x minus 4 is cancel. So it simplifies to 3x plus 3 over 4x minus 11. Next, we've got to look at that domain restriction. Lots to think about. Let's go back to our original expression. First of all, this is a denominator, so that can't be 0. Secondly, this whole piece is a denominator. So when we look at the simplified expression of that denominator, the numerator cannot be 0 because that would make the denominator of the complex fraction 0, and the denominator can't be 0 because the denominator can never be 0, so we've got lots to look at. So the denominator of our original fraction was x minus 4, so x cannot equal 4. The numerator of the simplified denominator is 4x minus 11, so x cannot equal 11/4. And the denominator was that quantity x plus 1, x minus 4, so x cannot equal negative 1 as well. And in case I lost somebody there, the three pieces were the denominator of the original numerator, the numerator of the simplified denominator, and the denominator of the denominator. So lots of pieces to think about with a complex fraction. We'll look at one more of those, and then we'll be done for this lesson. Again, in the denominator, we've got to combine our like terms. We have to do that in our numerator this time too. So in the numerator, common denominator is x. In the denominator, it's x minus 1. So I'm going to simplify everything all together this time. So our numerator, we've got 2 over x minus 3x over x. In the denominator, we've got x minus 1 minus 1 over x minus 1. Simplifying the numerator, we've got 2 minus 3x all over x. In the denominator, we've got x minus 2 over x minus 1 when we combine our like terms. All right, so now we are going to multiply by the reciprocal. So we have 2 minus 3x over x times, flip the denominator. And we have nothing that simplifies, so we're simply going to write this as 2 minus 3x times x minus 1. We can go ahead and leave it in factored form. You do not need to multiply these back out. And it makes it easier for figuring out the domain restriction. So since nothing canceled, I can look at the denominator of my, quote, simplified expression. So x cannot equal 0, and x cannot equal 2. However, we also have to think about the numerator of the original denominator, which we have, but actually we're missing, is when we flipped that denominator is what we were missing. So x also cannot equal 1. And last, your U-try questions. We've got one that's hidden at the bottom there, so go ahead and pause this. And there's your last U-try.